algebra discussion, population distribution and transition metrics. Today I'm going to talk about population distribution across different locations using a concept known as the transmission matrix. This concept helps us understand how a population tends to move among different states. Introduction to transition matrix. A transition matrix represents the tendencies of a population to move from one state to another over a given period. For simplicity, imagine a population divided among three states, which we call State 1, State 2, and State 3. The transmission matrix records the proportion of the population in each state that moves to each other state in the next time period. Properties of a transmission matrix. The matrix contains only non-negative values because negative populations movement isn't possible. The sum of the values in each column of the matrix must equal 1. This ensures that the total proportion of the population accounted for remains constant. Example of a transmission matrix. Consider a simple matrix with three states represented as follows. The first column might include 0 for state 1, 0 for state 2, and 1 for state 3. This means all the population from state 1 goes to state 3. The second and third columns can be set up similarly based on the specific population movement dynamics. Power of the matrix. Repeatedly multiplying the transmission matrix by itself, raising it to higher powers, can show us the population distribution over multiple periods. For instance, multiplying the matrix several times can help predict the long-term distribution of the population across the state. If we multiply the matrix enough times, we might reach a point where further multiplication does not change the matrix. This stable condition is known as the steady state. Achieving steady state. A steady state is a significant point where the population distribution does not change. With further transitions in mathematical terms, the matrix at steady state, when multiplied by the initial population distribution, results in the same distribution. This stable distribution has strictly positive values whose sum equals 1, representing the whole population. Practical application. To find the steady state distribution, you can look at the matrix after multiple multiplications or solve a set of linear equations derived from setting the matrix multiplied by a factor equal to the factor itself. Conclusion. Understanding and using the transmission matrix allow us to predict and analyze the movement of populations among different states. Effectively, it is a fundamental tool in many fields including ecology, economics, and urban planning. This explanation avoids mathematical symbols and focuses on a narrative understanding of how transition matrices function in the context of population distribution.